This is the third part of Lesson 7, Precalculus, Graphs of Polynomials, coming from Section 2.2 in the College Algebra textbook. And we're going to be looking at end behavior and multiplicities, starting with end behavior. To determine the end behavior of a polynomial, we're going to be looking at its leading term. And so let's think of that leading term as being f of x equals a times x raised to the power n, starting with where n is even. This is a monomial, and the graph of y equals x squared we're going to use for our first example. Here you can see that a would be greater than 0. It would be equal to 1. And let's look at what happened as our graph travels to the left. Note that it goes up. So going left, we also go up. As our graph travels to the right, it goes up as well. And this is important to keep in mind as we go on. Let's flip that graph across the x-axis so that we have the graph of y equals negative x squared. The exponent is still even here, but notice that now a is less than 0. A is negative. Well, as we go to the left here, our graph goes down. As we go to the right, what happens? Our graph also goes down. Now, let's look at the case where n is odd. So we'll use the function y equals x cubed for this example. Here, 3 is an odd power. 1, the coefficient, would be greater than 0. So what happens as our graph heads to the left, it goes down. As our graph heads to the right, it goes up. Now, flipping this graph across, I guess you could think either the x or the y-axis, we will have a graph of the function y equals negative x cubed, where the power is odd, but the coefficient a is less than 0 here. So as our graph travels to the left, it goes up. As our graph travels to the right, it goes down. Now we're going to use that end behavior that we've just been looking at to determine the end behavior of a polynomial with more than one term. But we look at the leading term here to help us out. And so in this case, with f of x equals 2x cubed plus x minus 5, we have a leading term of 2x cubed. The power on x of 3 is odd. 2 is a positive coefficient. And so our end behavior is going to be like that of y equals x cubed. As we go to the left, our graph travels down. As we go to the right, our graph travels up. Mathematically, we would write this as x approaches negative infinity, goes to the left. F of x approaches positive infinity, goes to the right. And did I do that wrong? As x approaches negative infinity, f of x approaches negative infinity as well. Sorry about that. It decreases. As x approaches positive infinity, f of x also approaches positive infinity. Okay, let's look at another example. Here we're looking for the end behavior of g of x equals negative 2x to the fourth minus x squared plus 1. The leading term is negative 2x to the fourth. The 4 is even. The coefficient of negative 2 is negative. So our end behavior will be like that of y equals negative x squared. As we go to the left, our graph travels down. We would write that mathematically as x approaches negative infinity. G of x approaches negative infinity. And we note that as our graph goes to the right, it goes down. So as x approaches positive infinity, g of x approaches negative infinity. And let's look at a third example here where we're wanting to describe the end behavior of h of x equals 2x times x minus 3 cubed times 2x plus 1 squared. Well, we don't have a leading term readily apparent here, but we can find it. We've done this before. We take 2x raised to the power of 1 times the leading term of x minus 3 would be x raised to the power of 3 times 2x raised to the power of 2, And then we'll simplify to get 2x times x cubed times 4x squared, or 8x to the 6th. So this is our leading term, 8x to the 6th. We have an even power on x. We have a positive coefficient of 8. So our end behavior is going to be like that of y equals x squared. The graph's not going to look anything like y equals x squared, but the ends of the graph are going to be heading in the same directions. We would say as x approaches negative infinity, h of x approaches positive infinity. As x approaches positive infinity, h of x approaches positive infinity. Okay, so let's look at the try on your own, number 3 for this lesson. Write the end behavior using mathematical notation. G of x equals negative 3x to the 7th plus 20x to the 5th minus 7x to the 4th plus 2x. Now let's look at multiplicities of zeros. And I have a polynomial here, f of x equals x squared times x plus 1 times x minus 2 cubed. We're going to find the zeros and their multiplicities. The zeros are the value of x that would cause my polynomial to be equal to 0. So we can see that x equals 0 would be a 0, x equals negative 1 would be a 0, and x equals 2 would be a 0. Their multiplicities are the power, well, you can think of the multiplicities as the number of times x appears here. It appears, if we wrote this all out, we'd have x times x plus 1 times x minus 2 times x minus 2 times x minus 2. So the number of times the factor appears that gives us that particular 0. So x appears 2 times. But we can kind of cheat and see that x is raised to the power of 2 here. X equals negative 1 comes from x plus 1. That factor appears 1 time, or we have an exponent of 1 here on x plus 1. X minus 2 gives us the 0 of x equals 2. It's raised to the power of 3, and we can see if we expanded this polynomial, x minus 2 would be present 3 times. Okay, so I hope this lesson goes well for you. We will be using multiplicities and end behavior when we start graphing soon.